In this video, we'll be looking at our final lesson for Chapter 1 and 1.8, Interpreting Graphs of the Functions. So our central question is, how do I interpret and describe the characteristics of graphs? So first we'll begin by looking at some definitions. We'll want to talk about what an x-intercept is again. This should be review. And that is where a graph intersects the x-axis. And the y-intercept would be where a graph intersects the y-axis. Linear is just referring to what kind of graph we have. Does it have some kind of curve to it, or is it just a straight line? Well, if it's just a straight line, it's linear. So linear is a graph that is a straight line. And then we have a line of symmetry, and all that does is it cuts a graph into two mirroring halves. A vertical line that divides a graph into two mirror images, meaning it's the same exact on both one side and the other. Okay, so let's look at some examples. All we want to do here is discuss whether or not the function is linear, a straight line, or not a straight line. We'll also estimate and interpret the intercept. So interpret means like what are the words that actually go with these intercepts. So if we look at number 1, it is a straight line, so we can say it's linear. And the y-intercept, it looks like it's around 0 to 50, 240, somewhere a little more than 240, so we'll say 250. So y-intercept is 0, 250. And what we can say is this, since it's starting at 0, but with our x-axis being generation since 2007, the 0 implies that we're talking about the year 2007. So the way to interpret that is to say the whale population was 250 in 2007. So at 0 to 50, we know that our year, it's 2007, because that's what our x-axis is telling us. And our y-axis is telling us the population, so we know there was a 250 whales in 2007. Our x-intercept down here looks to be about 10 comma 0. So this is 10 generations since 2007. So what we can say is the right whale population will be 0 10 generations after 2007. So that's how we can interpret these intercepts, actually giving some context and some words to these values. So let's look at our this number 2. We have our y-intercept down here. This is nonlinear. It's a curve, so it's not a straight line, so it's going to be nonlinear. We can see our y-intercept right there, so years since 1987. So we'll say that our y-intercept is 0, 1, it looks like. And our x-axis represents years since 1987. So for 0 years since 1987, that means the year we're talking about is 1987. And the y-axis represents dollars per gallon. So 1 would be $1 per gallon for gas. So we can interpret this as the gas price was $1 per gallon in 1987. Now x-intercept's off the graph, but what we could talk about is maybe just talk about this right here, this point. So our x-intercept, well, we're not going to call it x-intercept, we'll just call it the point of just a point of interest. So let's interpret this point right here, 25, 5. So I want to interpret that point so we can really see how this works. Well, this is 25 years since 1987. So we'd add 25 to 1987, we'd get 2012, and then we know the price is 5. So we would say the gas price was $5 per gallon in 2012. That's how we'd interpret this graph. So now number 3, we have our two x-intercepts and one y-intercept, and we'll first say that this is nonlinear. And our y-intercept is about, looks like we're going up by 80, so that would be about 640 right there. So we'll say that it's 0, 640. And this is telling us the height of the arch. The y-axis is the height of the arch, and the x-axis is the distance from the middle of the arch to the outside, to the outer edge of the arch. So we can say that the height of the arch, the maximum height of the arch, the maximum height of the arch is 640 feet. And if we look at our two x-intercepts, there's two of them now. We'll call them, let's see, 80, it's about 300, and we can say that the distance from the center of the arch is 300 feet on both sides. So that's how we can just look at graphs and actually put some context and some words to describe them. Okay, so let's go ahead and turn to the back of this page. So when we're talking about whether graphs are positive, negative, increasing, decreasing, what we're looking for is a few different things. So when we're positive or negative, we're just talking about their y values. So positive is where the graph is above the x-axis. So when we think about positive, we're thinking about our y values. So when we're above the x-axis, we have positive y values. And the negative is where the graph is below the x-axis. So being below the x-axis would give us negative y values. So we can say that this part of the graph and this part of the graph, our red pieces, are both positive. While my green pieces, since they're below the x-axis, we can say these are both negative. Now increasing and decreasing is just as you read it from left to right, think of it like a roller coaster. I'm going down, following the roller coaster, so I'm decreasing. Then I get to this bottom point, then I turn up and I start going up, so I'm increasing. So as we read it from left to right, reading from left to right, is it going down or is it going up? So increasing is where the graph goes up, and decreasing is where the graph goes down. So I'm going to shade these with my two different colors. So I'm going down from here to about right there, and then we're also going down from here to right there. So I'm decreasing here and I'm decreasing there, but in between these, right around this point, I'm going up until I get over to this point right around here. So right there I'm going up. So extrema are our relative minimum and our relative maximum. And a relative minimum has no other nearby points with a lesser y. So nearby means like very close to it. So say when I'm looking at this point, if I just look in this box right here, are there any points nearby this where's the only point that's the lowest y value? It's right here. I mean, if I look way over here, I'll see that there's lower y values, but they're not nearby. So you kind of zoom in, put your focus into one small area, and that's what you're looking for. And the same idea for relative maximum. Has no other nearby points with a greater y. So if I look in this area right here, I'll see that the greatest y is right there. And so our end behavior is kind of what's the graph doing as it goes off forever in those directions. So end behavior describes what the graph is doing as it goes on forever describes what the graph is doing as it goes on forever in the x and y direction. So as this graph goes on forever, we can think of it that my x values are getting less and less and less, but as my x values decrease, what's happening to my y values? So as x decreases, y increases. And then we can use the same idea for this right here. I'm discussing what's happening to y as my x goes on. So my x is now increasing. We can think of all these points. We can see the x is actually getting larger. But what's happening to the y as the x get larger? Well, as x increases, y decreases. So we're going to stop right here. We're going to let this be the end of the video. Don't even worry about these two examples. If we need to, we'll come back and fill them in during class. But I think just with a little bit of practice, all this vocabulary will start to make sense. So thank you for watching the video, and I hope you have a great rest of your day.